Welcome to 10.6. Find segment lengths in circles. Here's your circle, and here what we want to find are the lengths of these segments, these individual segments here. Now we are familiar that going from the circle to the circle, that is called a chord. And when two chords intersect, inside of, or in the interior of a circle, each chord is divided into two segments that are called segments of the chord. So here is a chord, and this has a yellow segment and a blue segment. And we want to be able to find the length of these segments. And what's really helpful is that when you have two chords that intersect with each other inside of a circle, the lengths of the segments will always be proportional. And in this particular case, the proportion is, like you see here, the yellow over the pink equals the green over the blue. And you could have swung it around like this, as you guys know, with similar triangles and so forth. You could have said green over yellow equals blue over pink, and so forth. Any of those scenarios will work, as long as you have on the left side and then go to the right side, that sort of arrangement. So that's a pretty simple proportion for us to create when we have two chords that intersect, and we are referring to the segment of the chord, or the segments, plural, of the chord. Let's also get some definitions though, because sometimes these segments intersect outside of the circle. And when they do, we either have a secant that is coming out. Remember, secant intersects the circle at 2 points and goes beyond the circle. And there is the external part of the external segment part of that secant, and then the internal, you could call it, but we will only refer to the external segment of this secant. And then we have the situation where the segment is a tangent. You will remember a tangent means it only intersects the circle at 1 point. And yes, the radius, the angle formed with the radius, is also 90 degrees. So when we have an intersection of two secant segments, in other words, we have a secant coming outside of the circle and another secant coming out of the circle. This is the proportion that we can set up between the lengths of those segments. And see what's happening here? We have the yellow on top of the blue, so it's a part over the whole, but it's not, the whole is not the whole of that one particular secant, it is the other secant. So I could say part of a secant, and it's the external part of that secant, over the whole of the other secant. See how that works? And then it's still part over whole with the other one. So here's the part of the other secant, or the second secant, over the whole of the first secant. So it takes a while to get that figured out. I put it in colors. Hopefully that'll make it easier for you to see. Again, part of one secant over the whole of the other secant equals part of one secant either over the whole of the other secant. Maybe that's the easiest way to say it. And then there's the other scenario when you have a secant and a tangent, a secant and a tangent. So let's wait on this, and let's first go over some examples of these two before we jump into the third. So here's an example of where we have an intersection of two chords, and of course it's intersecting inside of the circle. In order for them to be chords, they're going to only go inside of the triangle or the circle. And remember how we set this up? We can say let's do our fraction bar equals fraction bar. And so this segment of this particular chord, so x plus 2 over x equals x plus 4 over x plus 1. All that I'm doing is this pattern right here. Top left over bottom left equals top right over bottom right. And once we have this proportion, you know that we can solve for x by cross multiplying. And so let's kind of put parentheses around these to make sure that we understand these are individual expressions here. And I want to say x plus 2 times x plus 1. And that's what we have here on the right side of our equation. X plus 2 times x plus 1 equals, and then x times x plus 4. X times x plus 4. And so here's your equation that you want to solve, and we do that by distributing our x inside the parentheses. X times x is x squared. X times 4 is 4x. And then remember how we do this? When we have two binomials multiplied times each other, first we distribute the first term of the first binomial. So x times x is x squared, and then x times 2, it'll be 2x. And then we distribute the second term of the first binomial. So now distribute this 1 inside the parentheses. 1 times x is 1x. Remember before we had a 2x, so 2x plus 1x, that's going to give us 3x. And then 1 times 2 gives us 2. And so now here we have an equation, we have two squared terms. And remember, just like we did in 10.1, where we had squared terms on both sides, we can subtract that squared term from both sides, and they cancel out. So our x squared terms cancel out, and we have 4x equals 3x plus 2, and then subtract 3x from both sides, and we end up with x equals 2. The example that you have in your notes, number 2 here, is the same concept, but I've given you a very simple one with only numbers. You don't have a binomials that you have to multiply. We will do that in class, but let's just get accustomed to you first of all making sure to set up the proportion. So for number 2, set up the proportion according to this format here. And let's look at the other format that we have that we've talked about. So here, this is a secant that is coming outside of the circle, and it's intersecting the circle twice. Here is another secant that's intersecting the circle twice, and these two secants intersect. And remember, this is the external segment of that secant, and then 3 is the external segment of the other secant. And remember our proportion here, it is part over whole, where it is part of one secant over the whole of the other secant. And that equals part of one secant over the whole of the other secant. So in this particular situation, let's start with 5. We said 5 over, that's part of, hold on. That's the internal segment, didn't it? We want the external segment, so be careful with that. I almost made a mistake, which I do often, as you know, but let's do the external segment. So it'd be 4 over the whole, the other whole segment, or secant. So 4 over x plus 3, this entire length is x plus 3, equals, and here's the part, the external part segment of this secant, which is 3, over the whole of the other secant, which is 5 plus 4. So there's my proportion, and I cross multiply. So 4 times 5 plus 4, we have that, and then 3 times x plus 3. And then we just simply distribute. In this case, we just say 5 plus 4 equals 9. 9 plus 4 equals 36. And this one, we're going to distribute inside the parentheses. And then simply solve for x. Pretty simple. Hopefully we are getting this down with our algebra by now. Okay, so that's the scenario that you have there in problem number 1, where you have two secants that are intersecting outside of the circle, and you want to find this internal segment of the secant. So remember, start with the external. Always start with, yep, see, notice here the part is the external part of the segment, as is this pink here. So it'd be 6 over x plus 5 equals 5 over 9 plus 6. So put that proportion up here and then cross multiply and solve for x. Go ahead and pause the video to do that. And here's our third scenario. So again, make sure you understand, here is a first scenario where we have two chords that intersect inside of the circle. And then this paragraph here is just giving us terminology, definitions of things. And then here is a second scenario where we have two secants that intersect outside of the circle. And this third scenario is when we have a secant and a tangent line. Remember, tangent line intersects the circle only at one point, and yes, this would be a 90-degree angle with the radius there, but that's not significant for us at this point. And watch this proportion now. It's after you cross multiply, you will get the length of the tangent. So here's the tangent squared equals the part, and it's the external part of the secant times the whole secant. So when you do not have another, here we had a secant that went through, so we have two different parts. We have the external part and the whole. Well, with a tangent line, you don't have that. All you have is just the tangent line. So you take that tangent line and multiply it times itself, in other words, square the tangent line, and then that equals part of the secant times the whole secant. And that's the pattern that you need to use to be able to solve these last three problems that you have here. Let's go ahead and do this one for you. So here you have a tangent and a secant. This is the external part of your secant. But when you have a tangent, remember it's tangent squared. So here's the tangent, 16 squared, equals the part of the secant times the whole secant. So part is x, and the whole secant is x plus 8. So there's your equation. 16 squared equals, so it's the tangent squared, equals the external segment times the whole secant. And then simply distribute this inside the parentheses. X times x, remember that's x squared. And x times 8 is 8x, and then you can subtract 256 from both sides. And this is the standard form of a quadratic, and you want to then be able to use the quadratic formula. So let me show you the quadratic formula. Do I have that here quickly and easily available? I don't. I thought that I did. So let's go ahead and, because I was going to include that on some other notes. So let me give you the quadratic formula and put it in here in your notes. X equals, what is it, b squared plus or minus square root of, no, it's not b. It's negative b, there it is. Negative b plus or minus square root of b squared, yes, b squared minus 4ac. I think I got that right. Yes, I do. Over 2a. And that is when your when you have it in standard form, which is ax squared plus bx plus c equals 0. So first put your equation into this form the standard form for a quadratic formula, or quadratic form. And then you pull off the coefficient for the x squared term, that's a, that will plug in here. And the coefficient for the x term is b, and plug that into the formula, and so forth. And remember, this plus or minus means there's two different scenarios. One with when you do it as a plus, and then a separate time where you do it as a negative. So let me show you the example here that they do. And so here they have it in standard form. Here's your ax. In fact, it's very helpful after you put it into standard form to put it to write the standard form above that. Ax squared plus bx plus c equals 0. And so your a, in this particular case, is going to be 1. The coefficient, the invisible coefficient in front of the x squared term is 1. Your b is going to be 8, the coefficient in front of the x term. And then your c, your constant, is going to be a negative 256. And so now they plug it into, here's your quadratic formula again. X equals negative b plus or minus the square root of b squared minus 4ac, and all of that over 2a. So now you plug in, here's your negative b. Your b was positive 8, so you make it a minus a negative 8, plus or minus the square root of b squared, so 8 squared, minus 4 times a. A is 1, and then c is negative 256. And then divide that all by 2 times the value of a. In this case, the a is 1. And if you simplify this, simplifying inside the radical, you'll get 17 underneath the radical. So there's your answer. X is equal to negative 4 plus or minus 4 square root of 17. And if you want to, you can plug that into your calculator to find, first you do negative 4 plus 4 times square root of 17, and then you can do negative 4 minus 4 times square root of 17. So two different answers that you can have here. You can see it's approximately 12.49, or approximately, oh, actually in this case, that's interesting. In this case it ends up being the same. Is that right? Yeah, I guess. Oh, no. The positive value, there it is, that makes more sense. So the plus value is the only one that gives you a positive number, and that is the length. So that is the value of x, and that is the value, the length of segment RS. Okay, we'll go over these a number of times in class, but please try that. Use that quadratic formula. First put it into your standard quadratic form, and then use the quadratic formula like we learned back in Algebra 1. Hope that was helpful. May the Lord bless you, and I look forward to seeing you in class.